vector electric force. In the last examples and in the last stuff we did, we actually talked about the force between two charges. But most times we want to know the force on a particular charge and the direction in which the force is moving. So vector force is simply the magnitude of the force on a particular charge multiplied by the direction, which is the unit vector. Force is equal to magnitude. What we've been solving before, kq1 q2 over r squared, is simply magnitude multiplied by the unit vector. And this unit vector is simply the position of the charge feeling the force minus the position of the charge causing the force divided by the distance between them. And what do we mean by feeling the force and causing the force? Assuming we were asked to find the force on Q2 due to Q1. Q2 is feeling the force and Q1 is causing the force. So it's going to be the position of Q2 minus the position of Q1. Assuming we say find the force on Q1 due to Q2. Q1 is going to be feeling the force, Q2 will be causing the force. So we'll simply say the position of Q1 minus the position of Q2. So that's what we mean by this. Now, I believe you're going to understand better when we solve some questions on this. Question: two charges minus 3 microcoulombs and 4 microcoulombs are placed 3 meters apart. Find the vector force on Q2. This is the diagram. Q1 and Q2, they are 3 meters apart. Q1 is minus 3 microcoulombs, Q2 is 4 microcoulombs, and we are told to find the vector force on Q2. So Q2 in this question is feeling the force. That's the force on Q2 caused by Q1, which means Q1 is causing the force. To solve a vector equation, the first thing we have to do is to give these charges positions. If we choose this place as our origin, R2 will be equal to 0. R1 will be equal to minus 3i. But let's just choose this place as our origin. Irrespective of where we choose as our origin, provided we follow the steps correctly, we are going to arrive at the same answer. So if I choose this place as my origin, they have that R1 will be equal to 0, R2 will be equal to 3i, which means from 0 you move a distance of 3 in the positive I direction. So as we have given our origin and from the origin gotten our positions for different charges, then we'll apply the formula. F equals kq1 q2 over r squared multiplied by the position of the charge feeling the force minus position of the charge causing the force divided by the distance between them. So F21 actually means the force on Q2 due to Q1 equals kq1 q2 over r squared multiplied by the position of the person feeling the force minus position of the person causing the force. From the question they said find the force on Q2. So Q2 is the charge feeling the force. So R2 is the position of that charge minus R1, which is the position of the charge causing the force, divided by the distance between them. If we put in the parameters, we have that K is 9 times 10 raised to the power of 9. Q1 is minus 3 coulombs, which is minus 3 times 10 raised to the power minus 6. Q2 is 4 microcoulombs, 4 microcoulombs. Then the distance between the two charges is 3. So we have the distance squared multiplied by the unit vector. And how do we find that? The position R2 is 3i, so we'll put 3i there. The position R1 is 0, we'll put 0. The distance between them is 3, we'll put 3. So punching this in our calculator, we have that this whole stuff here gave us minus 0.012, and everything here gives us I. So 3i minus 0 is 3i. 3i over 3 is I. So multiply the 2, we'll have minus 0.012 I Newton. If we notice, we did not ignore the negative sign because we are looking for the vector force. So anytime we're looking for the vector force, we do not ignore the signs. We notice that the force on Q2 due to Q1 is going to be an attractive force because Q1 is a negative charge, Q2 is a positive charge, and they have to attract. So Q2 will feel a force that is moving towards the negative I direction, which is attracting to Q1, and that is why we should have a negative I force. So that is just common sense. So let's take a look at one last question. Two charges, Q1 equals 400 microcoulombs and Q2 equals 200 microcoulombs, are located on the xy plane as shown below. Find the vector force on Q1. Now, this is the diagram below. This is Q1 and this is Q2. And this is the distance from, let's just choose this place as our origin. So this is the distance from the origin. This is the distance of Q2 from the origin. So now, solution. From this equation, we could say from this origin, R1 is equal to 3J because it moves a distance of 3 in the J direction. R2, which is the position of Q2, is 4I because from the origin, it moves a distance of 4 in the I direction. Applying the formula for vector electric force, we have that the position of the charge feeling the force minus position of the charge causing the force all over distance between them multiplied by the magnitude of the force. Remember, in the equation, we are asked to find the force on Q1 due to Q2. So we write force on Q1 due to Q2 equals KQ1 Q2 over R squared multiplied by R1, that's the position of the charge feeling the force on Q1, so Q1 is feeling the force, minus R2, which is the position of the charge causing the force, divided by the distance between them, R. Now, how do we find the distance between these two charges? We actually need to use Pythagoras theorem. So square root of 3 squared plus 4 squared will give us 5. So R equals 5. So let's put in the values. We'll have that force on 1 due to 2, force on Q1 due to Q2 equals K is 9 times 10 raised to the power of 9 multiplied by Q1 is 400 microcoulombs, Q2 is 200 microcoulombs, R is 5, then R1 is 3J minus R2 is 4I. From this origin, we'll move a distance of 4 in the I direction, divide by 5. Punching this in our calculator, we have that everything here gives us 28.8. Then for this one, we cannot add or subtract J from I. 3J divided by 5 is 0.6J minus 4I divided by 5 is 0.8I. So if we simplify this, we should have 17.2J minus 23.04I. We could rewrite it as 23 minus 23.04I plus 17.248 J Newton. So depending on how we see it in the option in an exam. So this is all about vector force.